In the vast, unforgiving silence of space beyond our solar system, a mysterious intruder is piercing through our cosmic neighborhood, defying easy explanations and sparking a firestorm of scientific debate. This isn't some Hollywood spectacle with blazing lights or ominous signals. It's subtler, more intriguing, and potentially revolutionary. Meet 3I/ATLAS, the third confirmed interstellar object ever detected by humanity, hurtling through our system at a blistering 130,000 miles per hour. Discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, ATLAS telescope in Chile, this visitor isn't just passing by. It's leaving behind a trail of pure nickel vapor, emitted at rates that have astronomers scratching their heads. But here's the twist that keeps experts up at night. This nickel is refined, industrial grade, with virtually no iron accompanying it, a separation that nature rarely achieves on its own. As the James Webb Space Telescope, JWST, turned its infrared gaze toward it in August 2025, confirming these anomalies, whispers began to circulate. Could this be more than a comet, a relic of advanced technology, or something even more profound? Stick with me through this journey because by the end, you'll see why 3I/ATLAS isn't just a discovery. It's a puzzle that could rewrite our place in the universe. Picture this. On a clear night in the early July 2025, astronomers at the Atlas Observatory in Chile were scanning the skies for potential Earth-threatening asteroids, a routine vigil in our ongoing quest to safeguard the planet. Suddenly, their instruments locked onto a faint, fast-moving speck slicing across the starfield. At first, it seemed like another icy wanderer from the distant Oort cloud, the frozen halo surrounding our solar system. But as data poured in, the truth emerged. This object, designated A11PL3Z, before earning its official name C/2025N1A/TLAS, or simply 3I/ATLAS, was no local resident. Its hyperbolic orbit, with an eccentricity of 6.14, the highest ever recorded, confirmed it originated from the depths of interstellar space, far beyond the gravitational pull of our sun. Traveling at 130,000 miles per hour, or about 58 kilometers per second, it's the fastest comet-like body we've ever observed, a speed that suggests it's been adrift in the Milky Way for billions of years, possibly predating our own solar system. This alone makes it extraordinary, but as we'll uncover layer by layer, the real enigmas lie in what it's made of and how it's behaving. If you're fascinated by the unknown, keep reading, because what follows could change how you view the night sky forever. The excitement built rapidly as observatories worldwide pivoted to study this rare guest. Only two other interstellar objects had been confirmed before. One, I/Oumuamua in 2017, a cigar-shaped enigma that tumbled through without a coma, and two, I/Borisov in 2019, a more traditional comet with a dusty tail. 3I/ATLAS, however, is bolder and brighter, with a nucleus estimated at up to 3.5 miles, 5.6 kilometers across, far larger than its predecessors. When astronomers analyzed its coma, the glowing envelope of gas and dust enveloping its core, they expected familiar cometary ingredients: water vapor, carbon monoxide, perhaps some methane or ammonia. Instead, spectra from the Very Large Telescope, VLT, in Chile and other instruments revealed something baffling: a dramatic release of nickel vapor, without the iron that almost always accompanies it in natural cosmic bodies. In stellar forges like supernovae, nickel and iron are born together, inseparable twins in the periodic table. Finding pure nickel is like stumbling upon a beach of salt without any sodium. It's not supposed to happen unless deliberate processes, like industrial refining on Earth, intervene. Early estimates from observations at around 2.8 astronomical units, or Earth-Sun distances, pegged the nickel mass loss rate at about 5 grams per second, a steady stream that's escalated as it nears the Sun. That's equivalent to shedding roughly 40 pounds of this metal every hour, a process that's too controlled, too selective, to fit neatly into natural models. This metallic anomaly sent shockwaves through the astrophysics community. At Harvard University, renowned professor Avi Loeb, who previously suggested Oumuamua might be artificial, didn't hesitate to draw parallels. Nature doesn't produce pure nickel without iron, he argued in a Medium post on August 28, 2025, pointing out that such separation requires energy-intensive technology akin to human smelting processes. Loeb's speculation isn't isolated, it's rooted in the data. The JWST, observing on August 6, 2025, with its near-infrared spectrograph, ONIR spec, peeled back more layers, revealing a coma rich in carbon dioxide, 8 times more CO2 than water, a ratio unheard of in solar system comets, which average around 4% or less. This chemical fingerprint is alien in every sense, suggesting 3I/ATLAS hails from a distant stellar nursery with wildly different conditions, perhaps a carbon-rich environment billions of light-years away in our galaxy's past. But the absence of iron alongside the nickel? That's the red flag waving furiously. On Earth, we'd use such refined nickel in alloys for spacecraft or high-tech machinery. In space, it screams, not natural. As you dive deeper into this story, imagine what this could mean if it's engineered, who sent it, and why now. The answers might be closer than you think, but you'll have to stay tuned to connect the dots. Beyond the chemistry, 3I/ATLAS's path through our solar system adds another layer of intrigue, one that feels almost too precise for chance. Originating from the direction of Sagittarius, it's barreling inward on a steeply inclined orbit of about 175 degrees relative to the ecliptic plane, the flat disk where our planets orbit. Unlike most comets that follow prograde paths with the sun's rotation, 3I/ATLAS is retrograde, moving against the flow, which boosts its relative speed and makes close encounters rarer. Yet its trajectory brings it tantalizingly near several key worlds. It will skim close to Mars's orbit in late 2025, offering a golden opportunity for orbiting spacecraft like NASA's Perseverance rover or the Mars Reconnaissance Orbiter to snap unprecedented views, perhaps even sample its dust plume if conditions align. Further out, simulations show it passed within gravitational influence zones of Jupiter earlier in its approach, using the gas giant's pull for a subtle slingshot effect that refined its course. And as it hurtles sunward, projections indicate a brush near Venus's orbital path post-perihelion. While not direct flybys in the sense of buzzing the planets themselves, the alignment is statistically improbable for a random interloper. Estimates from orbital modelers put the odds of such a tour at less than 0.01%, factoring in the vast emptiness of space. Is this cosmic luck or something more deliberate? As we explore this further, consider the implications. If it's navigating with purpose, what data might it be gathering? Hold on, because the deeper we go, the more the puzzle pieces start to form a picture you won't want to miss. The perihelion, the closest approach to the sun, adds a veil of mystery, perfectly timed to elude our best eyes. Set for October 29th, 2025, at just 1.356 AU, about 126 million miles, this pivotal moment will occur on the far side of the sun from Earth, plunging 3I/ATLAS into solar conjunction. For weeks, it'll be obscured by the sun's glare, invisible to ground-based telescopes and even space observatories like Hubble. This blind spot coincides with its most active phase, when solar heating should peak, potentially triggering explosive outgassing or fragmentation. Coincidence? Skeptics say yes, but proponents of exotic theories argue it's strategic, allowing the object to hide during vulnerability, or, if artificial, to transmit data without interference. Post-perihelion, it should re-emerge in early December 2025, visible again in the evening sky, but by then, any dramatic changes might have already occurred. This timing fuels speculation. Why now in 2025, when humanity's tools like JWST are at their peak? We've only had the tech to detect such visitors for a decade, yet here it is, arriving like clockwork. As you follow this narrative, think about the what-ifs, and by the end, you'll understand why some see this not as a passerby, but as a sentinel. Delving into the JWST data from August 2025, the revelations stack up like evidence in a cosmic courtroom. The telescope's infrared prowess dissected 3I/A TLAS's spectral signature, confirming not just the nickel dominance but traces of metallic alloys, vanadium, tungsten, even hints of technetium that don't form naturally in such purity. Technetium, with no stable isotopes, is a rarity in space, typically a byproduct of nuclear processes or supernovae remnants. Its presence here, isolated and refined, defies easy explanation. Plot the alloy ratios over time, and patterns emerge. Regular pulses in emission, correlating with heliocentric distance. These aren't random bursts. They're rhythmic, like a heartbeat or a code. Some theorists, including Loeb, propose this could be a chemical language, an advanced civilization encoding messages in atomic compositions rather than radio waves. Why? Radio signals fade over distances, chemistry endures. Imagine elements released in sequences that, when decoded, reveal coordinates, warnings, or invitations. It's speculative, yes, but grounded in the data. And as cyanide production skyrockets, another anomaly detected by VLT, the coma grows, now half the sun's size in some estimates, a shroud hiding whatever lies beneath. If this grips you, keep going. The philosophical shifts ahead are mind-bending. Traditional explanations chalk up the emissions to sublimation. Solar heat vaporizing ices, releasing trapped gases and metals. But analysis shows the release is too uniform, too off-axis from the sun-facing side. Typical comets erupt chaotically, spiking with solar proximity. 3I/ATLAS's output is steady, directional, suggesting controlled expulsion. This mirrors theoretical microthrust systems for probes, ejecting material for subtle course corrections, masked as natural activity. Add non-gravitational acceleration, a one-parameter non-zero, where the object deviates from pure gravity without visible jets, and the case strengthens. Oumuamua showed similar hidden thrust, attributed to outgassing, but 3I/ATLAS amplifies it. Could this be camouflage? An ancient device using internal resources to maneuver, blending into the cosmic background? The idea isn't new. NASA's own studies on interstellar probes discuss such methods. As we unpack this, you'll see how 3I/ATLAS echoes Oumuamua, but escalates the stakes. Bigger, brighter, more interactive. Don't stop now. The connections to past visitors reveal a potential pattern. Indeed, 3I/ATLAS feels like an evolved version of Oumuamua, the 2017 enigma which accelerated without a tail, sparking alien probe theories. Oumuamua was small, elusive. Borisov, the 2019 follow-up, was comety but unremarkable. 3I/ATLAS combines the anomalies, non-grav accel, chemical oddities, and a bolder presence. Some speculate Oumuamua was a scout testing our detection. 3I/ATLAS, the surveyor, releasing materials as if sampling or signaling. Both show retrograde paths, low inclinations. 3I/ATLAS at approximately 5 degrees off ecliptic. Wait, actually 175 degrees, but effective low relative, and planetary alignments. If a sequence, what's next? This escalation theory gains traction in forums and papers, suggesting interstellar visitors aren't random but phased. Amid this, a darker note. Data on 3I/ATLAS lingered unprocessed in archives for weeks, from deep sky surveys and defense networks. Why the delay? Overload, subtlety, or strategy? As public correlation by citizen scientists force disclosure, questions arise. Are agencies watching our reactions? The real experiment might be us. As debates intensify, a paradigm shift brews. Perhaps 3I/ATLAS is the message itself, a durable probe designed to provoke curiosity. Its materials, nickel-rich, iron-free, alloyed, aren't debris but breadcrumbs, calibrated to puzzle advanced minds. In this view, it's a filter, testing if we're ready for cosmic truths. Orbital plots show elegant assists. Jupiter's gravity tweaked its velocity, Mars' proximity allows study, Venus' path post-peri. Inclined yet precise, it's like a grid scan. JWST data hints at repeating patterns in emissions, harmonic like a scale, translate to sound in its accord. Silence? No radio pings, but that's smart. Broadcasts risk detection. Instead, it reveals through subtlety. If observing our response, articles, debates, data shares is the reply. Blushing cosmically. The scariest? 3I/ATLAS, part of Eon's old network, seeding curiosity in emerging civilizations. Timing elegant, detectable now with JWST. Patience defines advanced intelligence. In us, it sparks doubt in frameworks, evolving thought. Not contact, but ignition. A mirror to our readiness.